Hello everyone, we are Team AI Scholar and we have done this project called Paper QA Plus, which is a multilingual RAG framework for research paper question answering with LLM comparison. So our problem statement basically is described by the fact that researchers have to waste a lot of time skimming long multilingual papers to answer narrow questions like what loss function was used, how big was the data set, what were the limitations. General LLMs hallucinate or they miss certain domain-specific information, and vanilla search doesn't help to summarize or cite precisely. So our goal is basically to build an LLM which answers user queries strictly from an evidence of curated corpus of research papers, and this is because citations lead to accountability of authentic information. This also supports multilingual queries, cites resources, and lets you compare different LLMs behind the same RAG pipeline. So the technology stack is as follows. Our backend is built using Express.js with TypeScript, which gives us both speed and type safety. For the database, we use MongoDB at last, and we interacted using Mongoose, which simplifies the handling schemas and queries. For authentication, we use two levels, Firebase JWT verification for secure login using phone OTP or Google sign-in, and Express-generated JWTs for granting controlled access to our chat features. For real-time communication, especially when we fetch responses from our fast API-based RAG service, we use server-sent services, SSE. Express acts as a proxy, so the app receives continuous streaming responses smoothly. We also use common libraries like JSON Web Token for handling tokens, XDOS for API calls, CORS for cross-origin support, .env for environment variables, Express SSE for streaming, and Morgan for logging in. So in short, this backend tech stack ensures secure authentication, real-time streaming, and a scalable database, which is all essential for a smooth user experience.
So coming to the RAG part, our goal is to move from simple retrieval to grounded tracing. We built a dedicated AI RAG microservice using fast API and LangChain, and the entire pipeline uses Gemini 2.0 Flash and for generation and Gemini embedding for vector embeddings. So the RAG service performs three major tasks. Like first, query classification. We classify each question upfront into specific research, generic research or non-research. And second, we use retrieval. For research queries, we pull context from the persistent ChromaDB, which is the research papers. And the third, fallback generation. If the KB doesn't have the relevant content, we automatically fall back to semantic scholar. This ensures answers are always grounded and never hallucinated. Now coming to the RAG pipeline. So here is the full RAG pipeline. First, the question classification. We first classify the incoming query so that we know how to route it. Second, the ChromaDB retrieval part. If the query maps to a known research domain, we pull relevant embeddings from the ChromaDB server. Next, the semantic scholar search. If nothing is found when we are searching for it, we automatically perform a live research lookup through the semantic scholar. Then the PDF processing is the paper is to open access. We fetch the PDF and chunk the first 10 pages and embed them. The fifth is the system prompt enforcement. Before generation, we enforce a strict system prompt that forbids unsupported answers and forces sorry, I cannot answer with enough evidence. This helps us to reduce the hallucination part. And the sixth, the response generation. Gemini 2.4 Flash streams the final grounded answer back to the backend. Next, the SSC delivery. Every token is streamed to the app through structured SSC payloads, giving the user real-time typing feedback. So this front end using React Native app. So on the mobile side, we built a complete React Native using Expo. Our front end stack includes Expo router for navigation, Zoostand for global state, React Native Paper for UI components, Axios and React Native SSE for streaming chat updates, Firebase authentication for OTP and Google sign-in, async storage for JWT and settings persistence. We also support full voice first interaction. In this section, we have included the integrations, voice module, storage, and security. Under and external integrations, we have Gemini 2.0 Flash embeddings through Google Gen AI SDK, Semantic Scholar API for live research discovery, Chrome HTTP server, voice module. We developed a custom native module for ultra low latency, a voice capture. It implemented in Java and Swift, and packaged as a standalone React Native module. Then a database storage. We use MongoDB Atlas for users, chat history and logs, ChromaDB for persistent embedding, which are the wrappers, FAS for fast in-memory retrieval for hydrated PDFs. Next, the auth and security part. We rely on Firebase authentication for OTP and the Google sign-in, JWT for session validity on Express layer, environment-based secrets for all API keys and sensitive configurations, CORS for plus middleware validation for the entire chat and pipeline. This ensures the entire system is secure, scalable, and production ready.
So now coming to the features and improvements for our project. So first is the end-to-end RAG service. So we implemented the RAG pipeline using Fast API. So it now performs query classification, retrieves relevant research papers from ChromaDB, and uses a semantic scholar as fallback. So the next feature is voice first interaction suite. So we improved the user experience by adding voice features. We integrated native speech to text for hands-free questioning and text to speech for reading answers aloud. So the next feature is secure secure authentication. So we now support Firebase, OTP, and Google Sign-in, and the backend issues secure JWT tokens for chat access. The mobile app also received a complete UX upgrade. There is new navigation, cleaner chat UI, markdown support, dark mode, and smoother scrolling. Now, coming to the operational handling and code quality, we added structured error handling for SSE streams, implemented safer prompts to reduce hallucinations, and it reduced fallback responses when information is insufficient. Yeah, so now coming to the workflow of the project. So if I am the user, I'll come to the app. Now first I'll log in. So this login is done by Firebase OTP. And then I will give a prompt for what I have to search. So basically, the client is sending a query which goes to the backend of Express and then the Fast API. Now the Fast API retrieves the answers from the purpose of the RAG and then it generates answers or it's streamed via SSE. Now Express relays streams. Through then there is a mobile UI update in real time. So now the MongoDB, which is our storage for database, it will store the chat history and then the user can replay, copy or listen their answers. So coming to the question and answering system of our project. So if user puts a question, it is an unanswered user question. So the initial query is sent to the backend. Now the backend will research in its original database if the answer is available. If it is not available, then it will check for the specific research paper from the keywords that the user has entered. Now the system will retrieve the knowledge about the question being asked, and then the query will be resolved with more confidence.
So this is how our system handles research queries. If the user asks about a specific paper, we first fetch it through the Semantic Scholar API. Then we extract key metadata like the title, abstract, authors, venue, and PDF link. Then we check whether the paper is accessible. If it is, we embed the PDF into a temporary FAISS store and use its content for context. If not, we fall back to using the metadata alone to generate the evidence-grounded answer. For general research topics, we start with Semantic Scholar's autocomplete endpoint to get the closest matching papers. We get the top suggestion, fetch its details, and use the information as context for generating the response. Overall, this flow ensures that every answer comes from the most relevant and authoritative source available, whether we can access the full paper or only its metadata. On the system side, we added a classification layer that blocks all non-research prompts to keep the assistant focused. A strict system prompt ensures every response follows Markdown, includes citations, and triggers a fallback when information is insufficient. All users are secured with Firebase authentication, and sensitive keys like Gemini, JWT, and Mongo are protected through environment variables. We also implement structured error handling over SSE to guarantee stable, real-time communication between the client and server. So today, research is shifting from manual reading to intelligent discovery. With Retrieval-Augmented Generation, RAG, we bridge the gap between speed and trust so scholars get fast answers that are fully grounded in evidence. Our system takes this further. It provides verified insights, speech-enabled exploration, and a persistent trail of citations that you can return to anytime. In simple terms, no more hallucinations, just accurate, explainable, and accessible knowledge wherever you are. So in this project, we built a cross-platform research assistant that delivers quick, citation-based answers. We implemented a full RAG pipeline, combining curated knowledge bases with semantic search for accurate retrieval. The system supports real-time chat streaming, voice input and output, and persistent conversation history. To maintain reliability, we added safety checks and fallback responses whenever content is insufficient. Overall, we demonstrated how LLMs, vector databases, and mobile interfaces together can boost research productivity. And this foundation sets the stage for future upgrades like multilingual retrieval, automatic PDF ingestion, and even multi-LLM comparisons.
So moving on to the demo of the app, I'll first start with logging in with Google. So yeah, here the authentication is completed now. So I'll move on by asking a simple question here. The equation. It is also able to answer sublingual questions. So I'll ask the same question in Hindi right now. So here they are. So right now, the text-to-speech is only available for English answers. So I'll just go on with answering this one.
Maxwell's equations are a set of 4 fundamental equations that describe the behavior of electric and magnetic fields
this is how
and
it
their
works.
interactions. They are the cornerstone of classical electromagnetic.
And another feature that we have is speech to text. So yeah, I'll just keep my hand. What is the difference between differentiation and integration? Yeah, so this is another feature, hands-free feature that we have here. Yeah, we're able to even read that. We also bring out dark mode here. Just switch between them easily. And then you can just go to your previous chat. Yeah, that was it for the demo. Thank you.